Hello students, welcome to AcadShala.
Let's roll on with 3R series, that is recall, revise, retrieve. Every accomplishment starts with a decision to try. So keep calm and carry on. And the success is ahead, always. Today we are going to start with the structural formula for alkanes from chapter 4, carbon and its compounds. But before that, I would like to retrieve that what are hydrocarbons. Compounds containing carbon and hydrogen are called hydrocarbons. Before starting structural formula for alkanes, we have already done the molecular formulae for alkanes in our previous video. So let's get started with the structural formula for alkanes. Now alkanes come under saturated hydrocarbons, and it is a single bond, and its general formula is CnH2n plus 2.
But before starting today's session, it would be great if you like this video, share this video and subscribe to our channel AcadShala. This gives us a lot of motivation to keep creating these kind of videos for you all.
So keep calm and carry on. And the success is ahead, always. Today we are going to start with the structural formula for alkanes from chapter 4, carbon and its compounds. But before that, I would like to retrieve that what are hydrocarbons. Compounds containing carbon and hydrogen are called hydrocarbons. Before starting structural formula for alkanes, we have already done the molecular formulae for alkanes in our previous video. So let's get started with the structural formula for alkanes. Now alkanes come under saturated hydrocarbons, and it is a single bond, and its general formula is CnH2n plus 2. So before this, I would like to little bit retrieve about the word root also. That if there is only one carbon, it is known as meth. If there are two carbons, it is known as eth. If it is 3 carbon, it is known as prop. If it is 4 carbon, it is known as bute. If it is 5 carbon, it is known as pent. And if it is 6 carbon, it is known as hex. This plays a vital role for writing the molecular formula and the structural formula for alkanes, alkenes, alkynes. So this word root is really very important. That is, this is the root of this topic, no matter it is molecular formula or structural formula. So little bit children, I would like to also retrieve the molecular formulae for alkanes, which is a single bond and comes under saturated hydrocarbons. We will quickly do it with the help of, that is the general formula CnH2n plus 2. We will place the values of n in the general formula, and then we will start making the molecular formula. So the first one comes out to be methane. That is, we have put the value of n is equal to 1 in CnH2n plus 2. Like suppose if I write it over here, the general formula just now first. Let me write the general formula so that we can proceed further by doing the calculation. Okay. So this is the general formula for alkanes I've written. Now what I will do, I will put the value of n is equal to 1 in this general formula, and I get the first hydrocarbon of alkanes, that is the single bond, is methane, CH4. So students, I have done in the previous video. You keep on calculating and do revision with me. So the second one is C2H6. Third one, C3H8. What I'm doing, I'm putting the value of n is equal to 1 in this. I got this formula. I put n is equal to 2 in this general formula. I calculated, I got this formula, and so on and on. So this is C4H10 This is C5H12. Keep on doing with me. And this is C6H14. So let us revise once again. This is methane. The first one is methane, ethane, propane, butane, pentane, and hexane. Am I clear? So we have revised the molecular formula also before doing the structural formula. Because children, for doing the structural formula, we need to know it. The molecular formula, which is really very important, the first step to proceed further in making the structural formulae for alkanes. Okay, now structural formula of alkanes. Now, first of all, you need to understand the basic which I told you in the previous video, that carbon is always satisfied by 4 covalent bonds. Always remember, children, that carbon is always satisfied by 4 covalent bonds. So, it should have 4 covalent bonds around it. It will never have more than 4 covalent bonds, or it will never have less than 4 covalent bonds. Because if it is less than or more than, that means more than 4 and less than 4, that means you have done something wrong in making the structural formula. So let us go for it. The first one is methane, which is shown over here. So let us write it for methane. That is, we know the molecular formula CH4. So knowing the molecular formula, keep on drawing the structural formula for alkanes. So the first one is methane. So this is central atom, carbon. And then on the 4 sides, we put, that is 4 these bonds. So the first one is done. Now the ethane, that means we are making first 2 carbons with single bond because it is alkanes, we already know. And then to satisfy this carbon atom, what I will do, if I see this carbon, so I have 1 bond with this carbon already. So I will put 3 more bonds so that to satisfy the carbon being tetrahedral. So now I will see this carbon. Because I am seeing that this carbon is also attached with what? That is 1 bond, and I need 3 more. That means to satisfy its tetravalency. Okay, this is the third one, propane. So I will make 3 carbons. Now, if I see this carbon, I need 3 more covalent bonds. Okay, I will satisfy it. Okay. Now, if I see the central carbon atom, it is having 2 already covalent bonds and 2 more I need it. Okay, fine. And this carbon is having 1 and 3 more to satisfy its tetrahedral structure. So, I have put. So, that means when you draw the structures, you keep on noticing that is it satisfied by its 4 bonds or not. So, this is the way to do it. So, butane, that means I have 4 carbons. Now, let us see this carbon. So, 3 more to satisfy. Okay. This carbon, 1, 2 I have, 2 more to satisfy its tetrahedral valency. This carbon, I have already 2. So, 2 more I will put. Okay. And in the last, I have 1 and 3 more to put. So, this way I will keep on doing my structural formulae. Okay, this 4 are done, children. So now the next one, pentane. So pentane means how many carbons? Okay, 5. So I will draw 1, 2, 3, 4 and 5. So let me do it now to satisfy its tetrahedral structure. So I have started doing it. This is having 2 already. I'm putting 2 more. This carbon is having 2 already. Putting 2 more. This carbon is having already 2. Putting 2 more. And this carbon is having 1. So putting 3 more. So it is done. Okay. Now let us do for hexane. Hex means 6. So I will make 6 carbons. 2, 3, 4, 5 and 6. Now let me satisfy all the carbons. Okay. 1 I'm having already. So 3 more to satisfy. Okay. This carbon 2. So 2 more to satisfy. And keep on doing it till you succeed in doing the structural formulae of what? of alkanes. And you know it, alkanes are single bond. And that is why we are showing single bond over here. And done. So this is the way, children, you should draw the structural formula. But before that, you need to know the molecular formula, which is really very, very important. See, these type of structures, you can draw it. So this is all about structural formula of alkanes, which we have done. That is methane, ethane, propane, butane, pentane, and hexane. Okay, so children, I wind up the session for today. So keep on revising. God bless you. Keep on rocking. Bye-bye.